This conference will now be recorded.
Very good morning, dear participants. Am I audible?
Yes, sir. Audible, sir.
Okay, thank you. So I welcome all of you to the next session of electromagnetic fields. So we are in the verge of completing the first module, and yesterday what we have seen is the divergence theorem. We have seen statement and proof we have revised. Along with that, we have seen two model problems of divergence theorem. First model is like they will be asking you to evaluate a particular surface integration. So how to start with this? From divergence theorem, okay, we know that surface integration of some vector dot n cap ds is equal to volume integration or triple integration of divergence of that particular vector dv, that is del dot that vector dv. So that is what is the point is, and we have seen second model also. Second model is like, by divergence theorem we know that these two are equal, that is volume integration, triple integration of del dot, for example, if the given vector is a vector, so triple integration or volume integration of del dot a vector dv will be equal to surface integration of a vector dot n cap ds, or I can say a vector ds. So these two will be equal, like that we have seen. And any student has got any doubts in that second model problem? If you are having doubt, you can ask me. Anybody has got doubts in model 2 problem, or it is okay? You understood yesterday?
No doubts.
No doubts. Okay. Divya B has got no doubts. Anybody else has got doubts? If you're having doubts, you please ask me, so that we can see. Otherwise, we will go to the next problem. Aishwarya is telling no doubt. What about B section? No doubts. Okay. Okay, ma. Okay, ma. I understand. So that's what we have seen yesterday. And one more thing I want to tell here: 99, 98 students are here. So the point is why I am sharing the absentees details in the class group is, see, you have to understand this particular GoToMeeting link is giving the time duration also. So I am handling class for 60 minutes, means you have to be available for the entire class, okay? But what is happening is some students are available only for 12 minutes, available only for 25 minutes. So those students also I am marking absent, okay? So you have to be available for the entire duration, then only you can understand, because we are seeing all the things whichever are important. Okay, so if you have missed actually yesterday's class, and also the class that was held on Saturday first hour, if you have missed it, definitely unit number 1, divergence theorem, that particular question you may not attend. Okay, because divergence theorem, statement proof, and also two model problems, all are very important for examination point of view, I am telling. Okay, if you have not attended these classes, definitely you are the loser, because these two topics are important. Model problems are also important. Definitely you may expect in the examination. Okay, so don't miss out. Yesterday, if you take, means by 4 o'clock I have started model number 2, but but before 4 o'clock, somebody, some 2 to 3 students, you left the meeting. Okay, so definitely you may not understand what is model 2 and how we have solved it. Okay, please understand and try to be in the link. Okay, this is my kind request. Okay, okay, with this particular point, I will share the PPT for today. I will share the screen. Okay, yeah, is the PPT visible?
Visible, sir.
Okay, thank you. So today we are actually covering the next topics in our uh, module 1. Okay, I think today or rarely by tomorrow we will complete our first module. Okay, so the left out portions are these things like Stokes theorem, EM model. EM model means electromagnetic model. Then units and constants, I can call it as. Then comes my identities. Then finally Helmholtz theorem. Okay, so these topics we will cover it one by one because all are simple topics actually. So agenda for today, it will go like this, like revision of the previous class. What we have done till now is the revision of the previous class. Then we will start with the sources and effects. So what are the sources of electromagnetism? What are its effects? Okay, which living thing may get affect due to this electromagnetic radiations, electromagnetic waves. Okay, that's what. Then Stokes theorem we are going to see. After that, electromagnetic model and units and constants we will cover. Then we will go to identities, that is null identities. Then finally Helmholtz theorem. And today I am planning to cover one more identity also, which is important. Okay, that I will give you a time today. You try to solve it, how to bring that particular answer. If not, we will cover it tomorrow. Then we will go for final summary. So as far as course outcomes are concerned, we are in CO1 now because we are in module 1. So CO1 is understanding of fundamental electromagnetic laws and concepts, which is coming under K2 level, understanding level of Bloom's taxonomy. So understanding of fundamental electromagnetic laws and concepts. Okay. First, coming to the first topic, which is sources and effects of electromagnetism. We call it as electromagnetic waves, whatever it is. So we will see first what are all the different sources of electromagnetic radiations or electromagnetism, we call it as. Okay, so from this slide it is well understood that we are having one universal source. Okay, where from it is very obvious that where from we are going to get electromagnetic waves or radiations. The universal, okay, universally available natural source is sun. So sun is the first thing where from I can get electromagnetic waves. Then we are using our mobile phone. That too, these last 1.5 years we are using mobile phones to a greater extent. So their electromagnetic interferences waves are there. Then in television, we are having it, microwave oven, we are having it, X-ray. We are having lot of sources where electromagnetic radiations or waves are actually available. Okay, so due to these radiations, what are the effects of these electromagnetic waves? Can anyone tell? Due to these radiations, which living beings are affected due to sun, mobile phone, television, X-rays? Due to this, what are the effects of having these electromagnetic radiations? Yeah, Merlin Anita, she has given birds and humans. Okay, definitely due to then animals. Anjali is telling animals, birds, humans, animals. Okay, these are all the living beings which are affected by these electromagnetic waves or electromagnetic radiations. Okay, so sources and effects you may expect in a 2-mark question. What are the different sources and effects of electromagnetic radiations or electromagnetism? If that is the question, the answer should be sources are where from somebody's mic is unmuted, please mute it. Okay, thank you. So if the question is like what are all the different sources, the answer is like sun, then x-ray, here there's a television, mobile phone especially, then comes microwave, oven, all these things. Okay, as far as the effects are concerned, humans, animals, plants, birds, or the things or the living organisms which get affected due to these electromagnetic radiations. Okay, so electromagnetic interference is such a dangerous thing. Okay, see, during your mobile phone, this thing itself, we know that due to waves only it is happening. This Android phone or signal which we are getting it from the mobile phone tower, everything is electromagnetic radiations passage. Okay, so definitely these are very, very essential. So due to this electromagnetic interference, only crosstalks are we are actually receiving while we are conversing with the other person. Okay, so all these things are due to electromagnetism. That's what I am categorizing under sources and effects. Next is important statement, we call it as Stokes theorem. Like divergence theorem, we are having something called Stokes theorem also. Okay, so Stokes theorem statement is, Stokes theorem states that the line integral of a vector around a closed path is equal to the surface integral of the normal component of its curl over any closed surface. We know already surface integration means obviously double integration of the normal component of its curl. Curl means we know it is the cross product. Am I right? Cross product. So it comes del cross H. So mathematical definition will be like single or what I can say, line integration H dl. Line integral H dl is equal to surface integral del cross H ds. So this is what is the mathematical definition of Stokes theorem. So Stokes theorem states that the line integral of a vector around a closed path is equal to the surface integral of the normal component of its curl over any closed surface. So mathematically, I am repeating it again actually. Mathematical definition is like line integral of H dl is equal to double integral del cross H ds. Okay, so as I said already, statement, grammatical statement will have 1 mark and mathematical statement will have another mark. So totally 2 marks. For this also, there is a simple proof will be given in your mobile app itself. You can see that what is the how to prove Stokes theorem. So actually they will be taking a sheet wherein it will be divided into some areas, some equal areas, like del s I can take it as some infinitesimal surface I can take it, and if I take the curl of it, what will happen is it will become the normal component of del cross H. I will get it. Okay, you can see it in the app very easily. It will be proved within 2 or 3 lines. You can prove it by taking this particular arrangement. Okay, proof is not that much important, but statement is important because these Stokes theorems and divergence theorems, they will form the base. Actually, we will be using it for the entire for the entire course, especially for 4th unit in which are where we are going to prove the Maxwell's equations. Okay, we'll be using divergence theorem and Stokes theorem in the derivations. Okay, so have these 2 definitions in your mind always. Okay, so line integral H dl is equal to surface integral del cross H ds is the statement of Stokes theorem. Okay, next we will be seeing something called EM model, electromagnetic model. So 2 approaches are there actually available in electromagnetic modeling. So one we call it as inductive approach, another one is deductive approach. Inductive approach and deductive approach. So what is inductive approach is, it is the process of reasoning from a particular phenomena to general principles. Then what is deduction or deductive approach means? It postulates a few fundamental relations from an idealized model. So deductive approach is the approach which will help us in postulating or formulating a few fundamental relations from for an idealized model, wherein inductive approach is like it is the process of reasoning actually why it is happening like this. Okay, that particular reasoning we can do it by means of inductive approach for from a particular phenomena to general principles. Okay, some example will also be given here. See, electromagnetic model, how to make idealized model, we are having some steps here. First step is like some basic quantities are to be defined there. First of all, for example, in the downstream downside of at the bottom of the PPT, you can see this particular slide circuit theory I am taking as an example, wherein, for example, if I am having my task is actually to find the transient response of a series RL circuit, right? What are the basic quantities that are available? There is voltage, current, resistance, inductance also I can add it here, conductance is given, etc. etc. means all the circuit elements like inductance, capacitance, everything can define it. Then what are the rules of operation that has to be specified? So we are for finding the transient response or to obtain the transient response characteristics, or to find the expression of transient current, what is our rule is we will be using Laplace transformation. Laplace transformation is the rule. And by using Laplace transformation, some fundamental relations are formed. Some fundamental relations are formed, or I can say postulated. So what relations I am postulating here is transient response. For example, if I take a series RL circuit, what is the transient current expression is I of t is equal to E by R. Okay, capital E or capital V by R into 1 minus e to the power R by L t. Okay, or I can say RT by L. So I hope you might have remembering this, wherein time constant of RL circuit is tau. Tau is given by L by R. Correct? So this is just an example of how to make an idealized model. Okay, so this is about electromagnetic model actually. So here we have to remember there are two types of approaches available. One is called inductive approach, another one is called deductive approach. That is important to mark. Okay, see, these things are just a base again. Units and constants means this is a general topic. So what is meant by SI units? This SI stands for International System of Units. For example, length is a parameter which will be measured or expressed in terms of meter. Time is a parameter which will be expressed in terms of seconds. Temperature, which is very popular nowadays, okay, due to this pandemic, it is either in degree Celsius or degree Fahrenheit. Okay, can anyone tell what is our normal temperature in Fahrenheit, body temperature? What is the typical value in Fahrenheit? Can anyone tell? What degree Fahrenheit is the reference one? Yeah, Renuka Devi has given the answer, 98.6 degree Fahrenheit. And Aishwarya is giving 369. What is this, Aishwarya? 369. I think you are giving it in degrees Celsius. Okay. So in degrees Celsius, it is actually Kelvin. Okay, 369 Kelvin. 369 Kelvin. Good. So degree Celsius means it is 37 degrees Celsius, and in Fahrenheit it is 98.6 degree Fahrenheit. They are the safer value. Okay, so if our body is sensing some heat, some high temperature we are running with, means the temperature, if I measure it using the thermometers whichever is available, right, like analog or I mean digital thermometer or whatever thing, you can see that the temperature value will be high, higher than 98.6 if it is in degree Fahrenheit, or greater than 37 if it is in degree Celsius. Okay, then normally mass, weight, all these things will be measured in terms of grams, or I can say the higher units like milligram, kilogram, like that, kgs. Okay, so this is about the base of units and constants. Very simple. It's the units we are going to use it. Okay, but in our course, okay, we will be specifically seeing about these four factors. So in electric field or in electrostatic field, we will be seeing about E and D terms. Electric field means electric field intensity, capital E, which is measured in volt per meter, V/M, volt per meter, and D, electric flux density, will be measured in terms of coulomb per meter square. Coulomb per meter square. Coulomb means it is capital C, C per meter square. And if I go to magnetic field, okay, I will be having magnetic field intensity or magnetic pole strength, we call it as. Its notation is capital H and expressed in terms of A per M, ampere per meter. You can see the comparisons. Electric field intensity means volt per meter, magnetic field intensity means ampere per meter. Then magnetic flux density will be there, so it is expressed in terms of Weber per meter square, or I can say equivalent unit is Tesla. Capital T, if I put it, means Tesla. So these four parameters we will be using it. If it is electrostatics, first two parameters, H and E and D, electric field intensity and electric flux density. And if it is magnetostatics, it is remaining two, that is H and B, magnetic field intensity or magnetic pole strength and magnetic flux density. These parameters are much popular. Then comes some relations. If I take electric field now, so as I said, E is the notation for electric field intensity and D is the notation used for electric flux density. Also, we call it as displacement density. Okay, this electric permittivity is given with some symbol. Can anyone tell what is the name of this symbol? This is a mathematical symbol. What is its name? Can anyone unmute and tell the answer? Yes, Pavitra. Anyone can guess, no issues. I am asking you to guess, that's all. I am not asking the exact answer. What
Eta,
is the
Eta, sir.
Eta? No, I think Divya Shri and another student, they have given the answer. It is epsilon. We call it as epsilon. Have you heard of this term, epsilon? Divya Shri, Damayanti, then Jeevanandam. These guys has given the answer. Very good. Pavitra is also. Okay, so it is epsilon. Okay, so electric permittivity will be given in the order of epsilon. So there is one relationship between this electric flux density and electric field intensity, that is capital D and capital E. How they will be related is D is equal to epsilon into capital E. So what is epsilon normally is epsilon is equal to epsilon naught into epsilon r, where epsilon naught is the permittivity at free space or air medium or vacuum, and its value will be given as 8.854 into 10 to the power minus 12 farad per meter. See, its equivalent value will be given by 1 divided by 36 pi into 10 to the power plus 9. Okay, 1 by 1 minute. I will do it. Yeah, almost 1 by 1 divided by 36 pi into 10 to the power plus 9 farad per meter. That value also I can use it. Or you just remember 8.854 into 10 to the power minus 12 farad per meter is the epsilon naught value. Then epsilon r is the relative permittivity of the medium. Okay, whatever medium is specified, that particular medium's epsilon or permittivity is said to be relative permittivity of the medium. So this is about units and constants as far as electric field is concerned. Okay, next comes my magnetic field. See, as far as magnetic field is concerned, what is happening is H, we will be calling it as magnetic field intensity or magnetic pole strength. B, I'm taking it as magnetic flux density, and I'm going to use some notation for magnetic permeability here. What is this notation named? Can anyone tell? For electric field, it is epsilon. Okay, good. What about this particular term? This symbol is
Mu, sir.
is called
Mu.
Yes, Priyadarshi. Mu. Yeah, you are right, Priyadarshi. Good. So this is said to be mu. Okay, magnetic permeability is said to be mu, and like the relation between D and E for electric field, D is equal to epsilon E. Here we are having B is equal to mu H. B is equal to mu H. Just you replace D by B and E by H, and also you replace permittivity epsilon by permeability mu. You will get B is equal to mu H. And in the same way, mu can be written as the product of mu naught and mu r, where mu naught is the permeability of the free space, vacuum or air, whose value is given by 4 pi into 10 to the power minus 7 Henry per meter. 4 pi into 10 to the power minus 7 Henry per meter, and mu r is the relative permeability of the medium. So there it is permittivity, and here we are calling it as permeability. That is the actual difference. Okay. Then we have seen two null identities in our first module. We have discussed and we have derived also. As I said, these two identities are said to be called the null identities because their right hand side's values are zeros or nullified. Okay, so del dot del cross A is equal to 0 is the first null identity, and second one is del cross del V equal to 0 is the second null identity. So how I can write as a statement is, for example, del dot del cross A equal to 0 means how I can write this. Actually, it is the divergence of the divergence of the curl of any vector field is identically 0. That is what is the statement. You got it? Actually, divergence means we are taking dot product. Dot product to which one we are taking it is the curl. So as I said, நம்ம prove பண்ணும்போதே பார்த்திருப்போம், right hand side we will be operating first. That is a del cross A we have done first. Then to the answer, what we have obtained from del cross A, we will be taking the dot product. Right? That is why it is given as the divergence of the curl of any vector field is identically 0. That is why, or that is I can write like del dot del cross A equal to 0. That vector can be anything. It can be A, B, X, Y, whatever it is. Second is del cross del B equal to 0. That means what we are doing is first we are operating del B. we are going to get a particular value. To that value, I am taking the cross product. So how I can write the curl of the gradient of any scalar field is identically 0. The curl of the gradient of any scalar field is identically 0. That is del cross del v equal to 0 is the second null identity which we have to remember. Is it okay? So these two are the null identities. Next, very important again, a 2-mark question which we call it as Helmholtz theorem. Helmholtz theorem. Okay. So its statement is very simple. F is equal to minus del V plus del cross A. So you know already, if I am taking, for example, A as some vector, so it is the addition, or I can say summation of two things. Number one, curl of a vector field A under del V. What is del V actually? Del V is nothing but the gradient of a scalar function. V is a scalar function means, so f is the general vector function f of any vector is the sum of the gradient of a scalar function and the curl of a vector function. We got it? So A is any vector. To that particular A, we have to take the curl. Along with this one, we have to add the gradient of a scalar function. If I do that, I will be getting the value for the general vector function f. Okay, this particular thing I am going to call it as Helmholtz theorem. Okay, so I can write like the top one also. That is, a vector field or vector point function is determined within an additive constant if both its divergence and curl are specified everywhere. A vector field is determined to be within an additive constant if both its divergence and curl are specified everywhere. I can state it like this. Another statement is the general vector function f can be written as the sum of the gradient of a scalar function and the curl of a vector function. Thus, I can write f is equal to minus del b plus del cross a, where a is the vector and del v is the gradient. You got this particular point? This is what I am going to call it as Helmholtz theorem. Okay, I'll go for next slide now, which is the last slide for today. And this particular identity only I told, which is another popular identity is there. This is that identity. Either it can be called curl h is equal to divergence of gradient h minus del square h. Or it can be written as a symbol del cross h is equal to del of del dot h minus del square h. So curl h is equal to divergence of gradient h minus del square h, or I can say del cross h is equal to del of del dot h minus del square h. Have you noted this particular identity? So we will start proving this identity now. Have you noted down?
Yes, sir.
Yes, sir.
Okay. Okay. I will stop sharing the PPT now because that is the last slide, and we will start proving that particular identity. And with that, we will close our session. Okay. So I will stop sharing the screen now. I'll get back to the video. So I am switching on the camera. Yeah, my board is visible.
Sir, visible,
Board
sir.
is visible to you? Okay, okay, thank you. Can anyone tell what is that identity? Curl H is equal to divergence of grade H minus del square H. I can write del cross H vector is equal to del of del dot H vector minus del square H. Am I right? Am I right? Curl H equal to divergence of grade H minus del square H. So symbolically I can write it as. Okay. So it's proof. Can anyone tell how to start with this derivation? First step, as usual, you try to assume H vector as. So let H vector is equal to Hx Ax vector plus Hy Ay vector plus Hz Az vector. Okay. Now what operation we have to do now? இதுதான் ப்ரூவ் பண்ணனும். லெஃப்ட் ஹேண்ட் சைடு எடுத்து ரைட் ஹேண்ட் சைடு ப்ரூவ் பண்ண போறேன். சரிங்களா? So left hand side அப்படினா எதை முதல்ல எடுக்கணுங்க? Which operation we have to do first? Either del cross del or del cross H. Which I have to do first? Yes, Pavitra.
Sir, del cross H, sir.
Del cross H we will do first. Del cross H means what will happen? A matrix has to be formed. Yeah. So what is the first row and what about the size of the matrix? What size I will get for del cross H?
Sir, 3 by 3, sir.
3 cross 3 because there are 3 unit vectors. Okay. So first row as usual it is unit vectors. Ax vector, Ay vector, Az vector. Second row is the coefficient of del. It is dou by dou x, dou by dou y, dou by dou z. Third row is the coefficient of h vector. So it becomes hx, hy and hz. Okay. So if I take the matrix, I mean this matrix determinant, what will happen? It will become Ax vector into dou Hz by dou I minus dou Hy by dou Z minus Ay vector into dou Hz by dou x minus dou Hx by dou Z. Then again plus Az vector into dou Hy by dou x minus dou Hx by dou y. Do you agree with this? Yes or no? Okay. Now to get the left hand side, what has to be done next is we have to take curl on both the sides. Now I am having del cross H. Yeah. Remember what I am doing is I am going to take curl on both sides. So what will happen if I take curl on both sides? It becomes again del cross H. That means to this particular vector I have to take another curl. So what will happen? Ax will be coming here, A will be here, Az will be here. Then here dou by dou x, dou by dou y, dou by dou z. Then here what will happen? First term will come, that is dou hz by dou y minus dou hy by dou x. This is a simple term. Okay. This term has to be interchanged because here minus ay is there. அப்போ இந்த மைனஸ் உள்ள எடுத்து போயிடணும். அப்போ முதல்ல எடுத்த உடனே அந்த டேர்ம் வந்துரும். hx by dou z minus dou hz by dou x. Third term dou hy by dou x minus dou hx by dou. So in this principle, am I right? என்ன பண்ணிட்டு இருக்கோம் புரிஞ்சுதாப்பா?
Yes, sir.
Now as usual, I am trying to find the determinant. If I take ax vector, what will happen? These two have to be multiplied. So it will become dou square hy by dou x minus dou square hx by dou y square. It is actually dou x into dou y, right? Correctly we have comes dou x dou y minus this one. Okay. Then minus these two products, dou square hx by dou z square minus of minus, it will become plus dou square hz by dou x dou z. This is the first term. யாருக்கு இது புரியல? first term புரிஞ்சுதாப்பா எல்லாத்துக்கும்? ax vector அப்படின்னா product of these two minus product of these two. So இங்க ஒரு minus இருக்கு, so minus of minus will become plus. புரிஞ்சுதாக்கா? ஏதாவது டவுட் இருக்குங்களா? இருந்தா then there you please ask me. Okay. அதே மாதிரி ay எழுதுறேன். ay என்ன ஆகும்? இந்த ப்ராடக்ட். So it becomes dou square hy by dou x square minus dou square hx by dou x dou y minus dou square h that by dou y dou z plus dou square hy by dou z square. Third term is plus az vector into dou square hx by dou x dou z minus dou square hz by dou x square minus dou square hz by dou y square plus dou square hy by dou y dou z. So in this way I will be getting three terms. Is it okay? Now what I'm doing in the second term la I will be making this ay as positive. இது எழுதிட்டீங்களா? இது எழுதிட்டு அடுத்த ஸ்டெப்ல ay நான் பாசிட்டிவ் பண்ணனும் அப்படினா என்ன ஆகும்? பாசிட்டிவா இருக்கிற டேர்ம்ஸ் நெகட்டிவ் ஆயிடும். So this term will become negative. This term will become positive. This also will become positive. This term will become negative. நான் என்ன பண்ணிருக்கேன்னா ay நெகட்டிவா இருந்துச்சு பாசிட்டிவ் பண்ணிட்டேன். அப்படினா மைனஸ் ஆன நான் பண்ணிட்டேன். அப்ப என்ன ஆகும்னா இது பிளஸ் ஆயிடும். பிளஸ் இருக்கிறதெல்லாம் மைனஸ் ஆயிடும். மைனஸ் இருக்கிறதெல்லாம் பிளஸ் ஆயிடும். சரிங்களா? இப்போ நான் என்ன ஸ்டெப் இங்க பண்றேன் அப்படினா, so what step I am going to do it here is ax vector into இந்த நான் ரெண்டா பிரிக்கிறேன். எப்படி பிரிக்கிறேன் அப்படின்னா இந்த ஸ்கொயர் ஸ்கொயரா வரும் இல்லையா, அதையெல்லாம் ஒரு பக்கம் வச்சுக்கிறேன். கீழே ரிமைனிங் எல்லாம் வேற வச்சுக்கிறேன். ஃபார் எக்ஸாம்பிள் நான் வந்து என்ன பண்றேன் அப்படின்னா அதே மாதிரி ஆடிங் அண்ட் மல்டிப்ளையிங், ஆடிங் அண்ட் சப்ட்ராக்டிங் டோ ஸ்கொயர் ஹெச்எக்ஸ் பை டோ எக்ஸ் ஸ்கொயர் ஆன் போத் தி சைட்ஸ், அதையும் பண்ணிட்டேன். இப்போ இங்க இந்த ஸ்டெப்பை நான் ஆட் பண்ணிட்டேன். இதை தவிர இங்க என்ன இருக்கும், hy by dou x dou y plus dou square hz by dou x dou z minus x vector into, நான் இதை சப்ட்ராக்ட் பண்ணிடுறேன் எந்த வேல்யூவை நான் ஆட் பண்ணது. ஸோ dou square hx by dou x square plus dou square hx by dou y square plus dou square hx by dou z square. இந்த ஸ்டெப் யாருக்கு நான் புரியல, இப்போ நான் எழுதியிருக்கிற ஸ்டெப் மீனிங் இஸ் பாருங்க, இந்த ஸ்டெப் ஒரே நிமிஷம் கவனிங்க. இந்த வேல்யூ இருக்கு இல்லையா, hy dou x dou y இங்க இருக்குது சரிங்களா, அதே மாதிரி இந்த வேல்யூ வந்து இங்க இருக்குது. ஓகே, அப்புறம் இந்த hx by dou y square வந்து இங்க இருக்குது, இந்த வேல்யூ பாத்தீங்கன்னா இங்க இருக்கு. நான் இப்ப எக்ஸ்ட்ராவா என்ன பண்ணிருக்கேன்னா I have added dou square hx by dou x square and I have subtracted it also. So add பண்ணி subtract பண்ணா எனக்கு ரெண்டு கேன்சல் ஆயிடும், இதே வேல்யூ கிடைச்சிடும் இல்லையா, அதனால நான் ஆட் பண்ணி சப்ட்ராக்ட் பண்ணிக்கிறேன், அப்பனால மேனிபுலேட் பண்ண முடியும் அப்படிங்கிறதுனால. இதே மாதிரி I am going to do it for ay and az also. இப்போ ay ல பாத்தீங்கன்னா நீங்க என்னத்தை ஆட் பண்ணணும் தெரியுமா, ay ல வந்து you have to add இங்க ஈக்குவல் வராது பிளஸ் a வெக்டர். இது கொஞ்சம் முக்கியமான क्वेश्चनங்க இந்த ப்ரூஃப் சரிங்களா, மேத்ஸ்லயே கூட நீங்க படிச்சிருப்பீங்க. இப்போ இங்க நான் என்ன ஆட் பண்ண போறேன்னா இதே மாதிரி இங்க பாருங்க x ஸ்கொயர் இருக்கு z ஸ்கொயர் இருக்கு, அப்ப நான் y டேர்ம் ஆட் பண்ணனும். நான் என்ன பண்றேன்னா இத முதல்ல எழுதிக்கிறேன், dou ஸ்கொயர் hx இந்த டேர்ம் by dou x dou y எழுதிட்டேன். செகண்ட் டேர்ம் I am adding this hy by dou y square voluntarily. Then I am going to write this term plus dou square hz by dou y dou z. இதை ஆட் பண்ணிக்கிறேன். minus ay vector into இதே மாதிரி ஒரு டேர்ம் பாருங்க, dou hx by dou y square, அதாவது சாரி dou x இந்த டேர்ம் பிளஸ் hy வரும் பிளஸ் dou square hy by dou y square. நான் இத ஆட் பண்ணது, இங்க ஆட் பண்ணிருக்கேன், இங்க சப்ட்ராக்ட் பண்ணிருக்கேன், பிளஸ் இந்த டேர்ம் dou square hy by dou z square. இதே போல நான் az க்கு என்ன பண்ணுவேன் அப்படின்னா I will add for example dou square h, அதாவது இந்த டேர்ம் dou x dou y இங்க dou x dou y dou x dou z இல்லீங்களா, அத நான் dou x dou z plus dou square hy, இப்போ நான் இந்த டேர்ம் எழுதிட்டேன், இந்த டேர்ம் எழுதுறேன் by dou y dou z. I am going to add now dou square hz by dou z square, that I am adding minus az vector. இதே மாதிரி ஒரு டேர்ம் வரும், dou square hz by dou x square dou square hz by dou square. இது நீங்களே எழுதிக்கலாம், இந்த இடத்துல வருது சரியா. If it is not visible you can write it on your own. அதே மாதிரி தான் y க்கு பதிலா x போட்டுக்கோங்க, கீழ இருக்கு இல்லையா, y க்கு பதிலா x z போட்டுக்கோங்க, கீழ x க்கு பதிலா x தான் சரிங்களா. இந்த மேல hy அப்படினா இங்க hz. Okay, so in this way we have to write it. அதுக்கு அப்புறம் பாத்தீங்கன்னா proof is going to end now, just 2 minutes. என்ன பண்ணனும்னு சொல்றேன், அது வரைக்கும் பாருங்க. இப்போ இந்த ஸ்டெப்ல என்ன பண்ணலாம் அப்படின்னு பாருங்க. இப்போ லெஃப்ட் ஹேண்ட் சைடுல ax வெக்டார் இருக்கு இல்லையா, இந்த பிராக்கெட் டேர்ம்ல இருந்து புரியுதுங்களா? இந்த பிராக்கெட் டேர்ம்ல இருந்து நான் என்ன வெளியிடலாம் அப்படின்னா டோ பை டோ எக்ஸ் மூணுலயுமே இருக்கு. ரிமைனிங் என்ன வரும் அப்படின்னா another dou hx by and another dou x plus dou hy by dou y plus dou hz by dou z. இது பாக்கி. இந்த இடத்துல பாருங்க மைனஸ் ax வெக்டார். இது என்ன எழுதலாம்? இது ஒண்ணும் கிடையாது, del ஸ்கொயர் hx. டெல்லோட இது என்ன டெஃபினிஷன் என்னன்னா உங்களுக்கு தெரியும், டோ பை எக்ஸ் ஏஎக்ஸ் பிளஸ் டோ பை ஏஒய் பிளஸ் டோ பை இசட் ஏஇசட்னு தெரியும் இல்லைங்களா? இன்னொரு டெல் கூட அதை பண்ணீங்கன்னா டெல் ஸ்கொயர் ஆகும். ஸோ இங்க டோ ஸ்கொயர் எல்லாம் வரதுனால டெல் ஸ்கொயர், ஆனா மூணுமே ஹெச்எக்ஸ் டேர்ம்ஸ். ஸோ ஹெச்எக்ஸ் அடுத்தது பிளஸ் ஏஒய் வெக்டர் கீழ இருந்து பாத்தீங்கன்னா டோ பை ஒய்யை வெளியெடுக்கு செகண்ட் டேர்ம்ல இருந்து. அப்ப என்ன ஆகும் அப்படின்னா டோ ஹெச்எக்ஸ் பை டோ எக்ஸ் பிளஸ் டோ hy by dou y plus dou hz by dou z. அதே தான் கிடைக்கும். இங்க வந்து minus ay வெக்டர் del square hy. third term az வெக்டர் into நான் இப்போ இத எடுக்கிறேன், dou by dou z வெளியேறா dou hz by dou x plus dou hy by dou y plus dou hz by dou z minus az vector into del square hz. சரிங்களா? இந்த மாதிரி ரெடியூஸ் ஆகுது. இப்போ இத வச்சு என்ன பண்றதுன்னா ஃபர்ஸ்ட் டேர்ம்ல பாருங்க இந்த பிராக்கெட் குள்ள போட்டு விட்டாம எல்லாமே காமனா இருக்கும். அப்ப என்ன பண்ணலாம் அப்படின்னு கேட்டீங்கன்னா அத வந்து நான் காமனா எடுத்துக்கலாம். அப்ப என்ன ஆகும்? இங்க பாக்கி இருக்கிறது பாருங்க dou by dou x ax vector, dou by dou y dy vector, dou by dou z az vector into the bracket line dou hx by dou x plus dou hy by dou y plus dou hz by dou z minus இங்க என்ன இருக்குங்க, இத வந்துட்டு நான் ஜெனரலா எழுதிக்கலாம் dou square h del square h. இப்ப இது வந்து என்னது? இந்த டெஃபினிஷன் உங்களுக்கு ஆல்ரெடி தெரியும் என்னங்கிறது. இது ஃபுல்லாமே வந்து டெல் தான், டெல்லோட டெஃபினிஷன் தான் இது, ரைட்டுங்களா? இது கூட வாட் ஐ அம் கோயிங் டு நவ, இது வந்து இதோட ஆன்சர் அப்படின்னு கேட்டீங்கன்னா டாட் டைவர்ஜோட ஆன்சர் மைனஸ் வந்துருச்சுங்களா? இப்போ ரைட் ஹேண்ட் சைடு equal to right hand side, hence the புரிஞ்சுதாப்பா என்ன பண்ணிருக்கோம்னு? யாருக்காவது டவுட் இருக்கா? முக்கியமான ஸ்டெப் என்னன்னு கேட்டீங்கன்னா இந்த ஃபேக்ட் ஆட் பண்ணி அதே ஃபேக்டரை மைனஸ் பண்ணுவோம் இல்லைங்களா? தட் பிளேஸ் தி வெரி இம்பார்ட்டன்ட். அதை பண்ணிட்டு நான் என்ன பண்ணிருக்கிறேன்னா இதுல இருந்து டோ பை டோ எக்ஸ வெளியெடுத்திருக்கேன். இப்படி அதே மாதிரி டேர்ம் வருது, அதே மாதிரி கீழே டோ பை டோ ஒய்யை வெளியெடுத்தேன், இங்க டோ பை டோ இசட்டை வெளியெடுத்தேன், காமன் டேர்ம் கிடைக்கும். இங்க ஆல்ரெடி பாத்தீங்கன்னா ஸ்கொயரா வந்துருச்சு, இப்படி ஆயிடுச்சு, ரைட்டா? இப்ப இங்க இருந்து இந்த மூணையும் நான் காமனா எடுத்துட்டு ரிமைனிங் வர்றது இங்க இருக்கு. இது என்னன்னு கேட்டீங்கன்னா உங்களுக்கு தெரியும் டெல்லோட வேல்யூ, டெல்லோட டெஃபினிஷன், டெல் ஆபரேட்டர் ஆர் நேபிள் ஆபரேட்டர் டெஃபினிஷன் தான் இது. ஸோ டெல்னு போட்டாச்சு. இது என்னன்னு கேட்டீங்கன்னா டைவர்ஜென்ஸ் ஆஃப் டெல், divergence of h a vector. So del dot h minus இந்த வேல்யூ. இதுதான் என்னன்னு கேட்டீங்கன்னா நம்மளோட ப்ரூஃப். ஸோ நம்மளோட ஐடென்டிட்டி என்னன்னு கேட்டீங்கன்னா del cross h is equal to del of del dot h minus del square h. இந்த டெஃபினிஷன் வந்துருச்சு அப்படின்னா ரைட்டுங்களா? ஏதாவது டவுட் இருக்காப்பா இந்த ஐடென்டிட்டி ப்ரூஃப்ல? போர்டை மூவ் பண்ணிடலாமா? Have you copied?
Yes, sir.
Okay, then we will close our session here. So with this, almost we are completing our first module. Okay, tomorrow we will start with the second module. Okay, thank you so much. We will meet again tomorrow.
Thank you, sir.